Hello everyone, welcome back once again to the topic called vectors. Okay, so today in this lesson we are going to deal with the motion in a plane. So first of all we'll be discussing about the expression for position vector. So now to explain the position vector, you just look at this picture what is shown here. You can see the point P in an XY plane. The point P in an XY plane. The point P representing the position. In order to express the position vector, we are using the term called what? R vector. Okay? R vector representing what? The position vector. Now from the picture you can see the position vector R vector is now resolved into two components. One is along x-axis and other one is along y-axis. Correct? Along the x-axis, what is the component of R vector? Xi cap. Along the y, what is the component of R vector? That is represented as yj cap. So we can write here in terms of vector addition. In terms of vector addition, we can write here OP vector. What is that? OP vector is equal to OA vector. See this one? OP vector is equal to OA vector plus OB vector. OA vector plus OB vector. Here what is the OP vector? From the picture we can see here that is the R vector. So R vector is equal to, now what is the OA vector? That is equal to Xi cap plus, what is the OB vector? That is equal to Yj cap. So this is the representation of position vector in terms of x component as well as y component. So we are discussing mainly about what? Motion in a plane. So there is only two axes are the x-axis and y-axis. Now let's discuss about the expression for displacement vector. Let's discuss about the displacement vector. So in order to express the displacement vector, you have to refer this diagram. So look at this diagram here. What is seen in this diagram? You can see once again this is a xy plane. In an xy plane, the black color line represents an object motion. Okay, so just imagine an object is moving in xy plane, in a one plane. Just imagine the body or the object is now reached at the point P. Reached at the point P. Take it as the time is equal to t. When the time is equal to t, the object is reached at the point P and the position vector is marked here OP vector. OP vector is equal to what? R vector. Now after some time, okay, after some time, say it as the time is now t dash. After some time, the object is now reached at the point P dash. So what is the vector notation? The OP dash. What is that? OP dash. OP dash you can see in the picture, it is equal to R dash. Now using the triangle law of vector addition, what is that? Triangle law of vector addition from the picture, you can write here that is OP dash vector. Okay, OP dash vector is equal to OP vector plus PP dash vector. OP dash vector is equal to OP vector plus PP dash vector. Where what is OP dash vector? OP dash vector we have marked it as R dash vector. What is that? R dash vector. Which is equal to, now what is the OP vector? OP vector we have marked here R vector. Now plus what is the PP dash? PP dash is the displacement. Displacement from initial position to final position. So what is the PP dash we have marked here in the diagram? That is delta R vector. Delta R represents here about displacement. So we can write the formula for displacement, that is delta R vector is equal to R dash vector minus R vector. So what is the basic meaning here? Displacement is equal to final position minus initial position. So this is the way we can find out the displacement of a vector. Now once again we can write this formula as delta R vector is equal to, now what is R dash? In the picture R dash means there will be x-axis and y-axis value will be there, no? So we can write here that is in terms of unit vectors, we can write here x dash I cap plus y dash j cap. That is a position vector. R dash is having two components, x dash I cap plus y dash j cap. Same way, have the component for R vector also, right? So we can write the word x I cap plus y j cap. That means x component and y component of R dash, same way x component and y component of what? R vector. If you rearrange this equation, we can write like this: delta R vector is equal to, write the I cap together, so we can write here x dash minus x into I cap plus, right, next one, y dash minus y into j cap. That means we can write this equation as delta R vector is equal to delta x I cap plus delta y j cap. So this is the way to represent what? The displacement vector. Basic formula for displacement vector, delta R is equal to final position minus initial position. What is this equation represent? We are writing in terms of rectangular components, the displacement become what? Delta R vector is equal to delta x I cap plus delta y j cap. So this is the way to represent what? Displacement vector. Now let's discuss about the average velocity terms in terms of rectangular components. Now let's write the equation for average velocity. As we already learned what is the displacement vector, so we can write here the average velocity, we are representing it as v bar. Okay, average velocity is equal to, what is the definition for average velocity? It is the ratio of displacement to the total time interval. So we can write here the displacement as delta R vector. Delta R vector is the displacement we have just now discussed, divided by the time interval is equal delta t. Here what is meant by delta t? Here delta t is equal to t dash minus t. Okay, t dash is the time when the object is reached at the p dash, right? So t dash minus t is the delta t. Now we can write this equation, average velocity v bar is equal to, now what is delta r? Delta r is equal to delta xi cap plus delta yj cap, right? So we can write here delta xi cap plus delta yj cap all divided by delta t. Now we can write this equation as the average velocity v bar is equal to delta x by delta t I cap, correct, plus delta y by delta t into j cap. We can write this equation as average velocity v bar is equal to, we can write the delta x by delta t, that is the displacement divided by time, that is equal to velocity, but along which axis? X axis. So we can write here Vx into I cap. Here also we have tried here what? Average velocity term in terms of rectangular components, plus delta y by delta t, we can write here what? Vy j cap. So this is the way, once again v bar y, this is the way to represent what? Average velocity in terms of rectangular components. In terms of rectangular components. So our basic formula, average velocity is equal to delta r divided by delta t, right? Look at the picture once again, the previous picture once again. You can see here the direction of the average velocity is same as the direction of the displacement vector. What is the direction of displacement vector? From p to p dash, correct? The same way average velocity direction is also in the direction of displacement vector. Clear? Now let's discuss about the instantaneous velocity term. Instantaneous velocity in a plane. Now let's discuss about the instantaneous velocity term. We have already discussed in this previous lessons. What is the instantaneous velocity? Velocity of an object at a one particular instant of time. And there we have discussed about when delta t tends to 0, what is the velocity, and that is called what? Instantaneous velocity. So in order to explain the instantaneous velocity concept, okay, look at some pictures here. So look at the first picture in this case. Look at the first picture. In the first picture, you can see once again the xy plane, the black color represents here what? The path of the object, and P and P1 represents what? The position. Okay, you can see here P is the initial position and P1 is the final position, correct? At what time interval? Say it as the time interval is now delta T1. Look at the second picture here. You can see here, look at this, if you look at the second picture, you can see the time interval is now, just imagine the time interval is now delta T2. Delta T2. The time interval is now reduced. Time interval is now reduced. If the time interval is now reduced, you can see here the displacement vector also now reduced here. When the time interval is reduced, the displacement vector is also now reduced. Now once again what we are doing here, just to take another time interval delta T3. So look at in the third picture, once again we are taking here at delta T3. The time interval is now once again reduced to delta T3. The displacement vector is also now reduced here. Now we are reducing this time interval in such a way that the delta T tends to 0. Delta T tends to 0. The time interval is tends to 0 mean we are going to calculate the velocity at one particular instant. Now look at the fourth picture here. If you look at the fourth picture, we can see the at one particular time interval, there we are dealing with the time here delta T tends to 0. Delta T tends to 0 mean doesn't mean that it's 0. The time interval is too small, in a fraction of second maybe. So at that time you can see in the fourth picture the direction of velocity is the tangent drawn at the point here. The tangent drawn, and that is the direction of velocity, and that particular point the velocity is called what? The instantaneous velocity. So look at the first, second, third and fourth picture. First picture the time interval is delta T1. Second picture time interval is delta T2. And again delta T3. It goes on, and finally we are taking the time interval is too small so that delta T tends to 0. There the direction of resultant velocity or the direction of that velocity is what? Tangent drawn at that particular point. Clear? So this is the way to calculate, to represent what? The instantaneous velocity in terms of vector diagram. Okay, now use the formula here. What is the formula? We can use it here. First of all, the instantaneous velocity we can write here v vector is equal to limit, we have already learned this equation, limit delta T tends to 0, delta R divided by delta R vector divided by delta T. So when you are applying the limiting value, then we used to say the term called what? Instantaneous. Now we can write this equation as v vector is equal to limit delta T tends to 0, delta R by delta T we can write here like this, delta xi cap plus delta yj cap divided by delta T. Correct? Can we write like this? Therefore, we can write this formula as the velocity, instantaneous velocity is equal to limit delta T tends to 0, delta xi cap divided by delta T plus, plus limit delta T tends to 0. Now, next term is what? Delta yj cap divided by delta T can be written as v vector is equal to dxi cap divided by dt plus dy divided by dt j cap in terms of differentiation, first derivative. So limit value we can write here dx by dt I cap plus dy by dt j cap. What is dx by dt? That is the displacement divided by time, that is equal to velocity in which axis? X-axis component. So we can write here v vector is equal to vxi cap plus here it become what? Vy j cap. So this is the way to represent what? The instantaneous velocity in terms of the rectangular components in a plane. So the only what? X-axis and y-axis. So how to calculate the magnitude of this resultant velocity? So the magnitude we can calculate v is equal to square root of the x component square. What is x component square? Vx square plus the y component square, that is a vy square. So this is the way to calculate what? The magnitude. Now you can also find the direction here. So we can find the direction as tan theta is equal to v divided by vx. Tan theta formula, tan theta is equal to vy divided by vx. Okay, the y component of velocity divided by x component of velocity. Therefore theta is equal to tan inverse of v divided by vx. You can calculate what the direction of the resultant velocity. So what all things we have discussed today here, that is a position vector and the displacement vector, average velocity and instantaneous velocity in terms of rectangular components, and we have discussed in what, in a plane. So only x component and y component. Okay, so I hope you understood this one. In the next lesson we will be discussing about the acceleration in terms of rectangular components. Thank you all of you.